We'll now consider a special type of series called an alternating series. And we're concerned with ones whose signs strictly alternate. So something like 1 minus 1/2 plus 1/3 minus 1/4 plus 1/5 minus 1/6 plus 1/7, etc. The idea being that the signs are constantly switching between positive and negative. This particular example can also be given in the shorthand notation, where we're looking from the sum from k equal to 1 to infinity of negative 1 to the k plus 1 over k. An alternating series are always going to have this negative 1 to the k plus 1 term, or just negative 1 to the k, depending on if the first term is either positive or negative. So let's look at the test for alternating series to determine if they converge. So we suppose we have an alternating series, negative 1 to the k plus 1 ak, equivalently negative 1 to the k, a sub k, and this is going to converge provided two things happen. The first thing is that a sub k is greater than or equal to a sub k plus 1. The terms should be getting smaller, or at the very least, not getting any bigger. And the second thing is that the limit as k goes to infinity of a sub k is equal to 0. So we need the terms to be getting smaller and the limit to be equal to 0. So let's look at a couple of examples. We're going to consider the sum from 1 to infinity of negative 1 to the k plus 1 over k squared. So the first thing that we need is that the terms are getting smaller. And we're specifically talking about terms using a sub k equal to 1 over k squared. The negative 1 to the k plus 1 was a separate part of our definition. So when we're considering the limit and if the terms are decreasing, then we don't need to consider the alternating sign part, the negative 1 to the k plus 1. We should feel pretty confident that k squared is less than or equal to k plus 1 squared. If I square a number and then I square a bigger number, I get a bigger number. I can then take the reciprocal of both sides, and when I do, that flips my inequality. So I now have 1 over k squared is greater than or equal to 1 over k plus 1 squared. So that shows me that a sub k is greater than or equal to a sub k plus 1. So I do have the first condition for convergence. The second condition looked at the limit as k goes to infinity of 1 over k squared. And we know this limit is equal to 0, which is exactly what we needed. So we can say this alternating series converges since both of my conditions have been satisfied. The next series we'll consider 2 minus 3 over 2 plus 4 over 3 minus 5 over 4, etc. I won't directly prove that this is going to be decreasing, but we should be able to look at these and feel pretty confident. I have 1 and then a smaller and smaller fraction as I go. So we should feel pretty confident that we do have the first condition, ak is greater than or equal to ak plus 1. What about the limit as k goes to infinity of a sub k? Once again, I don't have a direct formula for this, although it should be pretty easy to find one. However, we can see that the terms are always 1 plus a little bit of a fraction. And the fractional part is getting smaller and smaller and smaller, but the 1 isn't. If the top of the fraction is always 1 bigger than the denominator, this is always going to be slightly above 1. So the limit of this is actually 1. The alternating series test said that we needed this limit to be equal to 0 to converge, so we can say that this one diverges. The next one I'm considering, the summation from k equal to 2 to infinity of negative 1 to the k, ln k over k. Therefore, my a sub k's are ln of k over k, and this is what I'm going to be primarily concerned with. I need to start by seeing if this is decreasing or not. We should feel pretty confident that k is greater than or equal to k plus 1. While I won't prove this directly, you can graph ln of k over k and see that it is a decreasing function after k equal to 2. So we do have that a sub k is greater than or equal to a sub k plus 1. So now I need to consider the limit as k goes to infinity of ln of k over k. And we do need L'Hopital's rule for this. This is infinity over infinity. So L'Hopital's rule says I should be able to take the derivative of the top over the derivative of the bottom. The derivative of ln of k is 1 over k, and the derivative of k is 1. So now this is the limit as k goes to infinity of 1 over k, which is equal to 0, which is exactly what we wanted. Therefore, this series will converge.